Welcome to Maths with Bob. Today we're looking at another series application called time payments or loan repayments. And we're just going to look at how it works to start with. And I think always we try and develop the formula. So we always say that A1. Now, A1, what is that? Well, that's the amount owing after 1 month. Or you just have to look back and have a look at what the installments are. If they're quarterly, it'll be the amount owing after 1 quarter, etc. So we then develop the formula by saying, well, the banks are going to charge me interest on my principal, so that's going to be my principal, 1 plus the interest rate. Now, okay, that's going to be the interest rate per period, in this case per month, which would be 9 over 12, so it's about 0.75% per month, and to the power n, and n is my number of periods. In this case, n would be just 1. So let's just go back at this back here. 1 plus r, and we can actually rewrite r in a minute as well. So we're just going to put 1 here. Okay. Now we're going to now subtract off our monthly installment. Okay. Okay. So let's try and work out what A2 is, the amount owing after 2 months. Okay. A2. Now, how we develop this formula is like a bit of a recursion, I suppose. It's like A1. 1 plus, now it's going to compound interest for another period, and I'm now going to take off another monthly installment. Okay, so let's actually just work out what that would be if I now substitute A1 as the top expression. So I just have to say that this is really P 1 plus R minus M, okay, there, and okay, I just won't write the ones in at the moment, so it's times 1 plus R minus another M. Okay, what do I do now? Well, I just expand this out and I'll get, it was actually my principal has been compounded, you can see here, for 1 plus R times 1 plus R squared, minus my monthly installment times 1 plus R. So one of my monthly installments has some interest accumulated or attached to it, if you like, or accumulated some interest. Then we normally would rearrange this, so we'd say P 1 plus R to the power 2 minus M, and I'll just change this just to show this is M times 1. So I then would rewrite that as, I'll put square brackets here, 1 plus R. Now, when we can actually put that in brackets, might be a good idea, because, okay, here we are. So we are going to develop a formula, okay. We're now going to look at A3, and we'll just see what A3 is, okay. Hold on. Okay, well, what is A3, the amount owing after 3 months? Well, A3 would be the amount owing after 2 months, compound interested, or compounded, if you like. And then minus another monthly installment. Okay, so we're going to have to try and put this is A2, you can see here, P 1 plus R squared minus M, okay, 1 plus R. We need to compound this again for, okay, 1 plus R minus a monthly installment. Now when we multiply all this out, we'll get P 1 plus R, now it becomes cubed, minus M. We have now, okay, this final M has a 1 on it, but we have 1 plus R plus another 1 plus R squared. Okay, all right. You can see here we now are developing a formula, and there's a couple of things to note. A3, okay, first thing to note, okay, look at this, okay, the pattern, there's a 3 here, okay, there's a 3 here, but however, over here, there is actually only a 2, so we have to take note of how the pattern is developing, okay, and how are we going to solve this for the monthly installments, okay. Okay, so how are we going to solve this for the monthly installments? Well, we have to continue the pattern, so we'll just go, okay, now right at the end of the loan, we are getting a situation where we have, okay, after 240 months, or 20 years, times 12, we now have that the principal, okay, which was in fact 500,000, and the interest rate was 0.75%, so it's going to be 1.0075. That's now going to be to the power, following the pattern. Okay, so remember the pattern was this 3 here, okay, this 3 here, okay, so it's just going to be 240 here. Now minus m, again, we're going to have lots of these ones, 1 plus 1.0075 plus dot dot dot, and let's have a quick look at the pattern. The pattern was, okay, this was a 3, okay, this was a 2, so 1 less, okay, so this is going to say, well, the last term here will be 1, okay, 1.0075, which is 1 less, so 239. Now, interestingly enough, 1 to 239 is 239 terms, plus the one at the front makes 240. So, and we know that after 20 years we should have paid this off. So basically A240 is in fact 0. So this allows us now to solve this. Okay, 1.0075 to the 240 minus m. We're going to solve it for m. Okay. And this is going to be times the sum. You can see here it's a geometric series, a common ratio of 1.0075, but there are 240 lots of these, so we have to sum to 240. So we need to rearrange this, and you can just see if we put this term over the other side, we have m, the monthly instalment, will in fact be 500,000, 1.0075 to the power 240, all divided by the sum of 240 terms. And that's what we need to evaluate. So we're now going to put this in and just have a quick look. Okay, what is sum to 240? Well, here I just wrote on the bottom. It's actually the first term. Now the first term is a 1. Now it's 1.0075. So 240 minus 1. Okay, it's all over 1.0075 minus 1. Okay, so that's what's on the, in the denominator, and we need to actually use the calculator to try and work out what this is. Okay, how would we work this out? Okay, well, obviously we're going to need a calculator, but I think the first step I would normally do is just rewrite this as 500,000, 1.0075 to the power 240, invert the, and multiply by the fraction on the bottom here, 0.0075, and then divide all that by, you see here, 1.0075 to 240 minus 1, which you probably keep in brackets. And when you actually do this, you end up getting that, okay, your monthly instalment, okay, turns out to be about $4,500. Actually, it works out to be, if you work this out, $4,498.63. Now, over the life of the loan, you end up paying back about double. I think it turns out to be about $1,079,671. So over the life of that loan, you've actually repaid the bank about a bit more than $1 million. Oh well, thank you for watching, and remember, always develop the formula. Thank you. Bye for now.